share of this session, and just still need to remind all no internet, no recording, photos. Let's start the introduction of the team members, so that each captain please introduce your team members. So let's start with the photo.
The leader of the Life and team. My name is Cai Bingyi. This is Xu Weichen. This is He Yi. This is Li Chenggang. This is Su Yirui. Thank you.
Hello
everyone, I'm the captain Zhong Yixing, and they are my teammates Jia Jing, Wang Si, Wu Yizhen. Thank you.
Good morning everyone, I'm the captain from River 1, and I'm Yang Youyi, she's Yan Yutong, she's Chen Renzi, she's He Wenjing, she's Chen Yaoqi.
Hello everyone, I'm the captain of Team Metro, and my name is Kai, and my teammates are Hu Yongxiang, Wang Yanjun, Hong Hanchen, and Lin Hongyu.
Let us introduce the jury. So, my name is Zhong Zihong from National Synchrotron Aviation Research Center.
Okay, hello everyone. I'm D101 Chen. I'm from D101 PF2.
My name is Chen Hong, Zhongzhen University.
My name is Li Dongxi. I'm from Donghai University.
Good morning, everyone. My name is Jiang Zida. I'm from National Taiwan Normal University. Thank you.
So, let's start. So, please the opponent please change the report. 1 minute.
So I'd like to challenge your problem number 6.
Number 6.
What is the number?
Dripping water.
So I'd like to challenge your problem number 8.
Preparation of the recorder in 5 minutes.
program is the balloon is placed inside a cyanide reconet, sometimes used to wrap garlic and inflate it. The web will expand and shorten, studying the properties of this muscle. And this is the perimeter. The R is the radius of balloon. We will assume that the balloon is a sphere, and the angle here is theta. And here to here is the original length of cylindrical length. And this is our theory. The relationship between balloon elastic interchange show pressure, internal radius, and final radius. From the ideal gas equation, we know that the pressure in the balloon is equal to this. And the change of the pressure is equal to this. And Y is mean for Young's modulus, and the original P is the thickness of the balloon. And it's also equal to the inner pressure minus outer pressure. And this is change in length and width. And length is QR divided by sine type of theta, and this is width. And we can get this sentence, and we can get theta by the Newton's law from this sentence. And this is the fourth ds elongation relationship. The F means we have a 20 GW to 100 GW, and because the change of the volume is little, so we can assume it as a sphere. So we can get the volume is A times E squared is equal to triple R. And we all know that the pressure is equal to the force divided by the agent. So it's equal to this sentence. And the inner pressure is equal to outer pressure plus pressure from T and pressure from S. And pressure from T is equal to this sentence. From the sentence last page, we can know the sentence about B, and we get the B is like this. And finally, we get the length of final is equal to Q can be divided by f of sine theta. And this is our experiment setup. This is the balloon, and this is the cylindrical net. And this is the web, each for 10 GW. And this is the snorkel. And this is our inflatable device. We can control the volume of gas through open or turn off the valve and different amount of needles. And each needle is for 60 cc. And this is our experiment. This is the vessel balloon and different types of inflation, each time for 60 ml and 1 atm. We can see that because this is hard to explain the 3D graph, so we will separate it into several parts. First is the relationship between length and force. We can see that the data is also close to the theory, but in the 20GW, because of the weight is not enough to let it be stable in the experiment, so it will be much farther than the theory. And this is the relationship between B and S. We can see that all the data is close to a length. So we want to find out the relationship between the delta B and the force. And the number of windows, because all the data is like a knife. So this is the theory of delta P and number of windows, and this is our data from experience. So we can find that it's also very close to the theory. And this is the length and the number of needles, and this is our data from experiment. And as I say, the 22W will be farther than the other length and the theory. And this is the B and the number. And this is our conclusion. Our conclusion, we guess that increasing in fracture distance will make the shorter length, and adding the load is adding the force will make the length be longer and showing the less contact effect. And in the theory, we guess that it will be like this. And the elastic pen will have effect with bridges. And we also guess that it will be close to this sentence. And the force F will affect the deformation. And this is our guess about the length. And after the experiment, we find that the experiment is making our data in the theory. Thank you.
Okay, so you want to please question the report.
Sure. I want to ask, if you turn to page 8, I want to know that did you make sure the air pressure inside the bottle? Did you use the formula that will the relation between the air pressure? So do you make sure the air pressure? your air muscle?
No.
And because I think that the problem statement said that we need to focus on the properties about your air muscle versus the real muscle. So do you found any properties between these two? Okay. And in this case, I think that the line will be not as strong. It will reach the state relation. Do you think that that may be?
Sorry, time is up.
Thank you.
One, please prepare your presentation. Please take the floor.
Hello everyone, I'm the opponent Zhong Yishi from International Shanghai Senior High School, and today I'm going to propose the product number 2 air mask. And there is a Java statement placed above the inside of cylindrical neck as it sometimes used to mount the belly and inflate it. The neck will expand and shorten, investigate the properties of such a muscle. So we can realize about problem statement, we need to focus on the properties that in our external view, the air muscle, so we need to form property of this muscle. And my main focuses are the main properties of the muscle and the impact of the elasticity of the volume and the net to experimental result. And there is a review of the report about the theoretical model, and he used the conservation of the energy and ideal gas equation and the Young modulus. And I think he explain the process of the energy conversion that is great. But I think that is the lack of the force analysis due to the inflation process and didn't consider the loss of energy because I think that the muscle will have the work and I think the energy will lose because that when we inflate the balloon there will be the elastic potential energy but he didn't consider it but I think that there will be about the experiment is that he used the number of the popping and the scientific way to be his manipulator rule. But I think that in his experiment, he didn't consider the volume shape and length of the considering of the different elastic model and spherical. And I still don't know how the units. I think it is not accurate because about this data, I think that the net will have the LA. About the data analysis, he explained that the net length to be his data, but he didn't connect it with his theory because that in the short question time, I asked him that why the trend will be that, but he cannot connect it with his theory. So, and there's also the lack of the arrow bar. And about the discussion time, I want to discuss with his is about the model is a conversion of the energy. I think that is the most important part in this problem. And I will talk about the energy loss because I think that will affect the work down by the air muscle. And about the experiment, etc., I want to discuss the molecular variable and the stability of the state up and how does he measure that the relation between the work down by air muscle and the external force. And about the data analysis, I want to know that because he get the data, but he didn't clearly explain that what the data trend with his theory. So I want to know the relationship between the theory and the changing trend of the data, and the connection between the experiment result conclusion. And there is no more discussion. Thank you.
Let's start the discussion.
Also have a changing. Because I think that because you use this, and do you think that this theory can explain your data because that you pump the air into the volume and the pressure inside the air and the earth will increase together. So how can you use this formula to explain your experiment data? Because I think that you come back with many experiments. And about your data, can you turn to page 50? I want to know that the data trend, why do you know that the external, how much the external, do you think that the energy conversion is all about the external force because we pump the air into the body? Okay, so I think that we should focus on the work done by you say you use hand and you use the inflator to pump the air into the body. So I think that the work was done by the force that will pump the air into the body, right? And I think that will, you say that you use the same inflator. I think that is great because you fix the length of the inflator and it will increase this. So can you know what the energy will work in your air muscle? Because they will transfer in the energy so that your muscle can work, right? Okay, that's okay. What do you think? Okay, so I think that do you consider the work in the delta work inside your balloon? Because you say that inside the balloon the temperature will also change. So I think that will be some part of the energy change, and the pressure inside your balloon will also change, right? Okay, so I think there will be the first part that in the energy inside the balloon, and I think they will always equals to the have a relation about the because we use the balloon to be our like muscle, right? So what do you think that? Do you think that the initial elastic potential energy will also be change in your experiment? So do you consider it in your experiment?
In our experiment, we just manage it in another way instead of the energy.
Also, but you also said that your muscle total truly work, so the length of your neck will change, right? So I think that's because the muscle will have the work. So I think that we need to focus on the energy transfer. And I think that you did great that you find a chance that when you pump the air into the balloon, the length of the net will increase, right? And so what is your? I think that about your muscle is just like that. And what is the length? Okay, so you only consider that the length change during your experiment, right? So, but I think that in the air muscle, there will be also the very important change that's the width of your muscle. Do you consider it?
Yes, that is our experiment.
Yes.
And after we put on the net, it will be the beat, which means then we
So the B will gradually increase, right? Yes, and do you think that about your experiment, what is the trend of your net length changing?
as more as we interact it, the length will be shortened.
The length will be shortened. So do you think that we should connect these two changing data together? Because that I think that is you did great at. I think that is some there will be similar with the real muscle, right? Just like the antagonism, like our muscle when we work, and there was some part will be expanded and some part will be shortened. Yes, and I think that is we will get the properties that connect your real muscle and air muscle. And okay, let's turn back to the energy conservation. I think that there will also be the initial elastic potential energy, and about but I think that we should focus on the work done by your air muscle. So I think that can you turn back to your data about page 17? I think that I want to ask the L. What is the L? It's the length of the net. About the data, there is your theorized. How can you get this data?
We get this and use it.
I think the theory line is what? Okay, and this is the formula. So how to get a trend line? Next question. The 77. Because I think that your theory line is not. And what can you say that the theory line trend will like this? Because it's not gradually increase or gradually decrease. It just first increase and decrease.
It is like it is a square, so like the function it will be like
So, but I think that the theory line cannot fix your experiment because that about air muscle, they will affect by the elastic potential energy, right? So do you think that they can be fixed with your real data? Because I think that it makes a big difference between these two parts.
but in this way I think we don't analyze it through the energy, we just analyze it in another way.
Okay, and can you turn to next page? Why this data is relative late with this one, with your theory?
Sorry, answer.
Okay, and about the discussion time, I think that we talked about energy conversion, and I think that is the important point in this property because we need to find a connection between the real muscle and the air muscle. But I think he did the theory and to have the connection with his data that the net them will change. But I think that is not enough because that there about the air muscle, we should focus on the not only the length change, we should also focus on the width change, and that we can find some part of the property of the air muscle. And I think that he didn't explain the theory with his data clearly, and I don't think that the theory cannot fix this experiment. And that's all I think that should be.
Your, please, give your question.
You can consider page 18. Yeah, can you explain why it will be like the blue one is different from others? Why the blue one is not different than others?
I think that this theory cannot fix this experiment.
Because the function is like square, so
I think the square cause this. Okay, okay. Can you turn to page 17? Please turn this page. Okay, it's okay.
I think that the theory line will not be like that because that about the air muscle. I think the theory line will.
So you think their theory is wrong?
I think the theory line will they will gradually hit the saturation.
Can you turn to page 6? Can you explain what is the thickness of the balloon?
it's like this.
So it will affect this phenomenon. Turn to page 15. You have mentioned that the blue line is the blue point is the red point is below the blue point, and he assumed that the balloon as a sphere at first?
Hey, hands up. Reviewer, very
And a reviewer from number 1, and now I would like to review part number 2, and it's a problem statement. And overview of the presentation, the theory he used is an ideal gas coefficient of air muscle, and they use elasticity, and the theta solved by Newton's law form, and the force versus the limitation relationship. And the experiment, they change the volume of gas controlled by the amount of needles, and the time deflection, and the length. And we discussed F equals 20, and meaning that it's much stable than series. And the conclusion they made is increasing deflection extent make a shorter length of the radius. And he gave the result of the pressure and the value by chart. And the external force will affect the formation of the muscle. And the result is affected by the elasticity. And the result match experiment acceleration. And the reporter's strength is that he has a complete theory and understand the problem statement well, and can compare the theory and experiment, and have a good time control. But a suggestion I gave to him is that he didn't consider error bar, and didn't analyze the data, and didn't consider another environmental factor, which means that he didn't have an error bar, and lack of explanation of parameters. And he doesn't understand his report well, so he can't answer the opponent and my questions. And the good part of the opponent that she had a good expression, and she understands the problem statement well, and she has a good mind control. And the suggestion for her is she didn't understand the report well. So he just and she speak too much time on the theory, which is that on the blackboard. And I think she's not loud enough, so I can't heard it. And she get too much on opinions and didn't focus on the report. And the question part that she asked, did you make sure your air pressure? And he didn't. He decided to ignore it. And I think that it can't be ignored because you can't know how much does it affect the results. So I can't ignore it. And she asked, will there be energy loss? And they say there might be, but they ignore it. But we think it can't be ignored. Oh, it can be ignored because it's very small. And the discussion part that she asked, did you only consider length, standardization of date? Yeah, and they say yes. And we think that we should use information and consider length and the curvature. And she asked, how can you get the theoretical data? And she said by theory in page 8. And apparently it's a big problem. So we can't know the B and the theta variable over time. And she asked that, are you sure the ideal gas law is correct in your environment because temperature vary? And she said, and we think that he should make sure how temperature affect and use data to decide if ignore it or not. And the question from me is that I asked that, did you agree that they assert balloon as a sphere?
Okay.
And they disagree.
Hands up. Order, please.
And this is the concluding remark. The discussion. The ideal gas function isn't accurate in this experiment, and the extra force caused the balloon length longer. And third, the very accurate and connection with the where data so are remarked. We should consider other parameters that cause the balloon drift or inflate.
Okay. So start the question from the board. Any questions?
Maybe let me start from the could you show your slide on page 17? It's just some kind of lines versus force. Yes. According to your data, it seems that the length is almost constant. You think that makes sense for real muscle? I mean, with real muscle, the length of the muscle will be keep constant as you increase the force. No? So why? How do you explain your data? Just briefly.
I think we can become this with real market muscle because how they work is different.
Let me switch to the proponent. Okay, maybe you can answer the same.
I think that this theory cannot work in. I didn't say that this is correct because that we all know that the muscle they will have the maximum, and I think that the real theory line will be like this. It will really hit to the saturation.
Yeah, okay. But then why his data looks like that? Why? Do you think?
I think that it's unreasonable, but
Yeah, why is it unreasonable? Just briefly.
yeah.
What he did wrong if it doesn't make
Yes,
sense?
because the string part is like here. The then will not at first is decrease and increase and decrease.
I know. You said it should be something like that. Increase and saturated, right?
I think that the then will gradually decrease because that the then is the then will be shorter. But I think that will not increase.
Maybe the will. Maybe you make a guess why his data looks like that. It doesn't make sense, right?
I think it's because of the fatigue.
Because of what?
Fatigue.
No, okay. Maybe one more. Okay, maybe let me stop here.
Another question? I just said, I just still follow this question. Okay. Because according to your theory, this is a theory, right? Not experimental effect, right? But at the number 4 is about 60, you can see there's a peak index, right? But it also shows up in your experimental data. Okay. And secondly, the number is very consistent throughout the time. So can you explain why there's a peak at 60 from your theory? Because there's no experiment effect now, right?
So we are talking about here.
Yes, but I'm talking about the peak. Sorry, and the number is coincident, 20, roughly.
Because as we calculate we need to know the sigma in this experiment, so we calculate in Newton's method. So I think it's probably in that part, but I'm not actually understand a lot.
Maybe that's one
I
more
think this phenomenon
question.
has-
Okay.
I think this phenomenon has a maximum, and in this situation, the maximum is 60. 60. Yeah. So,
Yeah.
I think that is not unreasonable.
No, let me ask some more questions. Maybe you can get more points. Yeah. But maybe on the opponent, you said energy loss is important, but you don't
Sorry.
discuss much. Maybe just briefly tell us why the energy loss is important in this case.
Sorry, I think that the energy will transfer there because he used the volume, and I think that the energy will not spread this. I think we should focus on the energy conversion, and that's my fault. But because in his experiment, he only said the muscle, the
But
muscle
just
that.
tell us why the energy loss is important in your opinion.
I think that sorry, I think that the energy conversion is important because that it will also give to the inside the temperature and the pressure will also change, and the elastic potential energy will also change. So that is not an energy loss. Sorry.
So please stop the break. So let's start the score with the reporter. 4, 6, 4, 5, 4. So the opponent?
6, 7, 7, 8, 6. The reviewer. 6, 6, 6, 6, 5. Take about 10 minutes.